Hello, this is Jason with scienceandmath.com, and today what we're going to do is build a very simple battery, believe it or not, out of a lemon. It's very simple to do, and it's a great way to learn about what batteries are and how they work. All you need to do this experiment is a copper penny, just a regular old copper penny. The cleaner the penny, the better. You will need a nail. Now you need to make sure this nail is a galvanized nail. It's very easy to find. Just go to the hardware store, look in the nail section, read the box. Most of them are going to say galvanized. All right? And then also you'll need obviously a lemon. Just any old lemon will do. Believe it or not, these three items, the copper penny, the galvanized nail, and the lemon are just enough to make a battery. So to actually do it, it's very simple. First, what we want to do is put on our safety glasses, just in case, you never know. And if you're a youngster, you need to make sure and get a grown-up to help you with this part, because you will need to use a knife. So what you do is you just make a little bit of a cut into this lemon, just a little slice, just big enough to kind of insert this penny, right, until it's halfway sticking out, just like this right here, all right? And then you take your nail, and right next to the penny, you go ahead and insert it just like so. Just stick it on in there. It doesn't really matter how far you stick it in or anything. Believe it or not, you have just constructed the world's simplest battery. And it's kind of hard to believe, but it's true, because inside this lemon is an acid. You know, think of citrus fruits, citrus oranges. Well, there's citric acid inside of this lemon. And so we stick two different kinds of metals in this lemon. One of them is a copper penny. One of them is a nail. It's galvanized. That just means it's coated with zinc. Two different kinds of metals inside of an acid makes a battery. Now we'll talk about exactly how it works later in more detail, but right now let's just see if we've actually built anything. So what I have here is a voltmeter. Basically one of these guys, if you have one laying around, it sure does make it a lot more fun because you can measure what you've done as far as building this lemon battery here. But even if you don't have one, you can still have some fun. I'll show you how to do that in just a moment. So what we have here is our lemon battery that we've built, and on top of it I have a regular old AA battery. Now, as you know, all batteries have a positive and a negative side. For this battery, this is the positive side, the side with the kind of the thing sticking out at the top. That's always positive. Of course, it's labeled as well, positive. And negative is the other side. So when you turn this meter on to measure voltage, right, you always want to try to stick the red guy on the positive side. So when we do that, we measure, for this new battery here, 1.55 volts, 1.5 volts is what we measure here. What's a volt, by the way? A volt is just simply a measure about how much push a battery has to push the electricity out. So you can think about, you know, if you're going to send electricity out of a battery, something needs to be pushing those electrons out of the battery. And the voltage, the higher the voltage, the more push is available to send that electricity out. So what we're going to do now is see if we've constructed a battery here. We have the penny on this side, we have the nail on the other side. We'll put both terminals on, and we will see we have 0.75 volts. So we can see we do have a voltage across these two terminals of this little lemon battery that we've created. So again, this guy's a little, you know, obviously more powerful. It's got more voltage, 1.5 volts. This guy has less voltage, you know, because it's built out of a lemon, right? So, you know, you might say, well, hey, if it were so easy to construct these batteries, why don't we just make 1 million lemon trees and make 1 million lemon batteries, and they'll be basically free, right? We can just power our iPhones and iPods and computers with lemons. Well, it's not quite that easy. You know, there's a lot of things going on inside of this lemon battery that I'll explain to you here in a few minutes to teach you exactly why it's producing electricity. But for now, just suffice to say that this lemon, that the acid inside and the chemistry and everything going on inside is not really strong enough to be able to produce a lot of electricity. So even though we can measure it with this sensitive meter, it's not able to produce enough electricity to really power a typical device like a camera or a phone or anything like that. So that's why we build these batteries here with the concentrated acid inside and the materials to really make a nice powerful battery. All right, so before we get into trying to explain exactly what's going on here, I want to point out something to you that you may or may not have figured out on your own so far. This guy, for this battery, 1.5 volts, I have the red guy against the positive terminal. If I flip it around like this, then I'm going to get exactly the same voltage, but I'm going to have a negative sign. Notice here there's a negative sign on that meter, right? So if you ever see a negative sign, it just means that you flipped the direction of your measurement leads. So when I connect it in the proper way, red on the positive side, I get a positive number. That's what I want. Now when I hook it up to my lemon battery, I also get a positive number now here. What this means is that this penny is the positive terminal, just like this over here is the positive terminal. The nail of this lemon battery is the negative terminal, just like this over here is the negative terminal. Notice for both measurements, I get positive numbers when I hook them up like this. So think of it this way. When you build a lemon battery, penny is positive, P for P. Penny is positive, nail is negative. That's pretty easy, right? Penny positive, nail negative. That's the way you can really, really easily remember which side's positive and which side's negative. All right, now before we get into actually explaining what's going on in here to see how the battery works, let's see if we can use this battery to do something. Here I have probably the cheapest calculator that I could find, the most inexpensive, no-frills calculator that I could possibly find. And what I would like to do is see if I can use these lemons to power this calculator, because most of these calculators that we have nowadays really don't take very much electricity at all to work. If you were to hook this up to a light bulb, it wouldn't work, because a light bulb requires, believe it or not, a lot of electricity to move through that light bulb to light it up. These little electronic calculators, they don't take very much electricity, so we might be able to get it to work. So what we're going to do first is open this guy up. Now again, if you're going to do this, I recommend that you do it with the cheapest calculator you can find, something that you don't mind if it gets destroyed, because you're probably going to destroy it here. Now notice what we have on the inside here. We have a circuit board. You know, we don't care what's inside of there, but on the top we can see, notice this particular calculator, it has a solar panel. Let me turn it on for you just to show you that it does work. It's got a solar panel, right? But it also has a battery. So that means that if you're in the dark and the solar panel is not functional, the battery will power the thing. So what I'm going to do, just to make this easy, is I'm going to take my pliers and I'm actually going to try to pop this battery out. Actually, it's probably going to be easier just to pull this red wire. I'm literally just going to disconnect it like that, and I'm going to pull this other wire out and just kind of rip it out. So I don't have any more battery power anymore. These guys are not functional, but I still have the solar power. So if we flip it over and if we turn it on, the calculator still works even though we remove the battery, because we have the solar panel. So obviously if we want to make sure we're powering this guy with the lemon, then we want to make sure that we're doing that. So what I'm going to do next is take this solar panel and really carefully try to remove this guy off like that. So now we have nothing connected. Now if we turn it over and we turn the calculator back on like this, you'll see absolutely nothing is happening. So the thing is obviously not powered. We've taken the solar panel off, and we've also taken the battery off. All right, so we have our calculator ready to go. We have our lemon battery ready to go. So let's go ahead and take some of these terminals here and try to connect it together. Now notice inside this calculator, the people that built the calculator, they have a black wire that went to the solar panel, and they also had a red wire that went to the solar panel. The red wire is always associated with positive in electricity, and I tried to teach you that a little bit earlier. The black wire is always associated with negative. So we're going to use black and red here to hook our battery up. We already talked about the fact that the penny is positive, so we're going to hook the red guy up to there, and we already talked about the fact that the nail is negative, so we're going to use that guy there. Now, it's probably not going to work with just one lemon, but we'll give it a shot, because like I said, these lemons don't produce very much electricity. So I will do my best to clip this guy on here to this guy like this, and then clip this to the other side, try to clamp it down really good, like that. Now let's go ahead and gently, without disconnecting anything, turn this over and turn it on. And I've got nothing. Let's just double check, make sure everything's connected. Everything's connected on the back, but nothing's working. So why do you think that's the case? It's because of what I told you a minute ago. These lemon batteries, they can produce a tiny amount of current, a tiny amount of electric current, but not very much current. So what we need to do, much like in an electronic device you might have to put 2 or 3 regular batteries in, we're going to probably have to connect 2 or 3 or 4 or 5 or however many it takes lemon batteries together to be able to power this calculator. So let's go ahead and do that right now. Going to disconnect these guys here. I'm going to go ahead and leave these wires connected to the inside of this calculator, and I've already kind of constructed some more of these lemon batteries over here. So let me scoot the calculator a little bit to the right. Okay, everything's still connected on the back. I'll scoot it over a little bit to the right. And so here is another lemon battery. And what I will do in order to hook these things together, grab another one of these alligator connectors. Now the way you hook these guys up is much like a regular battery. When you have these regular batteries and you hook them end to end, right? You've got positive, negative, positive, negative. You go end to end and you have basically a higher voltage, okay? So we need to do the same thing here. Positive, negative, positive, negative. They have to kind of alternate like that. And what we're going to do is hook the inside guys together. All right, so we're going to hook the inside guys together. Now remember, we got about 0.7 volts out of this battery before. So now if we hook, since we've got these guys connected across the inside, if we hook the outside terminals together, we should measure both lemons together, and now we get about 1.2. It's just about double the individual voltage that we measured before. So we have a higher voltage than we did before. Makes sense. 2 lemons, 2 batteries in series, we should get a higher voltage, and that's what we get. So now that we have that squared away, let's go ahead, let's leave this right over here. Let's go ahead and connect this guy, positive terminal to red, negative terminal to black, and look at that, the calculator came alive, right? We can of course turn it off, we can turn it on, all right? And so we have 25 times 4 equals 100. And just to make sure you understand there's no trickery going on here, the only thing we have on the back here, we've got a battery that we've completely taken the wires out of. We don't even have a solar panel anymore. I've completely removed that. And so we have the power going into this guy directly connected to these lemon cells. Now, I want to make sure that you understand, though, that the only reason this was able to work is because these electronic calculators, they really require almost no electricity. They're so good at building these calculators. The batteries last forever. They don't require very much, and that's why we can power it with a couple of lemons. If you try to hook a light bulb up to this, if you try to hook a motor up to it, if you try to hook anything that requires more electricity, you're going to be disappointed because it doesn't produce very much electricity here. But it does produce enough of a trickle for these 2 lemons to power this calculator. Now what I would like to do to close the section is try to do my best to explain why, because as we've talked about before, science is wonderful. Let's learn, let's do experiments, let's do cool things, but let's also try to figure out what's going on here, all right? What you have going on inside of this battery, I'll just point and gesture to this one right now. What you have going on inside of this lemon battery is you have an acid. We've talked about it. It's called citric acid, right, inside of this guy. And you have a nail that's galvanized. That means that nail is coated in zinc. That's done at the factory. That's why we needed the galvanized nail. And we have a pinion that's made of copper. It's really important that both of these metals are different. It makes for a better battery, and that's why we've chosen it this way. What's really happening inside of this guy is this nail is becoming oxidized by the acid inside of this battery. So you may have heard of that word oxidized before. You know, if you take a piece of iron and you put it outside, outside in the weather and let it sit there for a few months, we say it oxidizes, it turns to rust. What that means is that iron sitting outside is losing electrons. Right? And so it's losing the electrons, it's giving those electrons up to the oxygen in the air, and it forms iron oxide. That's called rust. Rust is not good. We don't like rust. You get a rusty car, not good, because rust is not very strong, right? We don't like rust. But that's what oxidation is. What's happening inside of this battery is this zinc that's on this nail is oxidizing right before your very eyes, so to speak, inside of this acid. The acid in the lemon simply provides an environment where the oxidation can really happen and do a good job of oxidation. So this zinc is losing electrons, right? It's losing electrons. That's what oxidation means. Where do you think the electrons go? Well, they're not just going to just sit there. They're going to try to go somewhere. When we hook them up in an electric circuit, the electrons bleed off of this nail, go through the circuit, in this case through the calculator, come back to the positive terminal, which is the penny. And that's why the nail is negative. The nail's negative because it's the guy donating and creating the electrons. It's not really creating them. It has the electrons inside of the nail, but it's donating them to the circuit. They go through the circuit, they come back around, and the penny is sort of trying to attract these electrons and kind of take them in. And that's what what you have here. And that is the fundamental concept of any battery. If you could take this apart, this little AA battery, I don't recommend it, but if you could, you would see an acid in there and you would see metals in there. And it's the same kind of chemistry. One of these metals is donating its electrons, and then the other metal is accepting the electrons, after the electrons go through the device, through your iPod or whatever, the other side of the battery takes those electrons in, and after a while, you basically deplete the ability of these metals to create more electrons, and the battery is dead. So if I hook this guy up and leave it for a few weeks or whatever, eventually this lemon battery will actually die, and it won't be able to produce any more electrons because the chemical reaction going on here is going to stop. Once you oxidize too much of this zinc, it can't go on forever. You kind of deplete what's there, and so you can't do it anymore. That is the fundamental of battery technology. It's pretty exciting. It's very easy to do. Make sure you get a very cheap calculator. The cheaper the better, because it'll require less electricity. This calculator literally cost about $4 at the drugstore, so you can get them. 2 lemons, a penny, a zinc nail, which is galvanized nail, hook them up in series like this, and you have a nice demonstration for anybody. One more thing, depending on the calculator that you have, you may actually need 3 lemons or 4 lemons or 5 lemons. I didn't even know until I did it how many I would need. So go ahead and have a few handy and just continue connecting them in series the same way that we've done these two, and eventually you'll reach enough electricity that you can actually power this calculator. I'm Jason with ScienceandMath.com. I hope you've enjoyed this. Go and get these materials, do this experiment, show your friends, and I think almost anybody would agree it's pretty darn impressive.